Hello everyone, we're on module 10 right now, and the first video we're going to talk about today is temperature. Before we talk about temperature, I thought I'd give you a little background. First off, there's a definition in your textbook for thermal equilibrium, and that states that anytime, or I should say when all physical properties are no longer changing, two materials are at the same temperature. Think of it as dropping an ice cube in a hot cup of coffee. Whenever you drop the ice cube in a coffee, naturally the ice cube melts, making it water, and eventually they all become the same temperature. But first let's define what temperature is. Temperature itself is a quantity of a substance that determines what direction heat will flow. Now, in that example, the ice did not give anything to the coffee, but rather the coffee gave heat to the ice. Some people think that the ice gave coldness to the coffee. And in actuality, there's no such thing as cold. We just use the word cold to describe a lower temperature or a material that has less heat. When we say it's cold outside, we're comparing it to days that have more heat or that are warmer outside. Because always, in nature rather, heat will always flow from higher temperature, or what we consider hot, to lower temperature, to what we consider cold. Because heat is a quantity that can change hands back and forth between different materials, objects, substances, whatever. And cold is not something that transfers back and forth. Now, when something cools down, so to speak, it's losing heat, or heat is escaping it, and heat is going to the surrounding air or whatever. But you can't add cold to anything. Now, you can't add colder air, for instance, in air conditioning. That's really an unnatural process. When I say unnatural, you have to introduce something extra, that is work, typically through a compressor, like, for instance, say an interior of a refrigerator. But in nature, those things don't happen on their own. There has to be something else working them. But in temperature, we have different temperature scales. And the rest of this video is going to deal with the three major temperature scales. Originally, early 1700s, a man by the name of Gabriel Fahrenheit came up with a certain temperature scale, which we call the Fahrenheit. And just a quick sketch it, say this is our temperature scale. In Fahrenheit, you had two significant temperatures, 32 degrees and 212 degrees. That's the freezing and boiling point of water. He chose water because water is one material that transfers between states of matter in a relatively low temperature scale. In other words, he goes from solid, which is ice, to liquid, which is water, to gas, which is water vapor, with relatively low range of temperatures. Now, he started off with a scale that he preset, and then he measured those freezing and boiling points on that scale. That's why they're at weird numbers. When the metric system came around, a man by the name of Andrew Celsius said, okay, let's take Fahrenheit scale, let's just make this 0 and make this 100 to make it simpler. And that's exactly what they did. So if you want to find a Celsius temperature, given the Fahrenheit temperature, you take 5/9 times the quantity of that Fahrenheit temperature minus 32. And you'll see an example in a minute here, but basically you take the Fahrenheit temperature, subtract 32, and then multiply it by 5/9. Likewise, if you arrange that for a Fahrenheit temperature, you take 9/5 times the Celsius temperature, get a number, and then add 32 to it. Then came the Kelvin scale. Kelvin scale is based off of what's called absolute zero. Absolute zero hasn't happened yet, but is estimated to be at about negative 273.2 degrees Celsius. So if we go on a temperature scale, and say here is 0 degrees Celsius, say negative 273.2 is right here, that is the beginning, or 0 Kelvin on the Kelvin scale. There are no negative Kelvin temperatures. So basically, say for instance, if we had a 20 degrees Celsius temperature, we wanted to convert to Kelvin, well from here to here is at 20 degrees Celsius. To get to absolute zero, we have to add that additional 273.2, which is how we get the formula here. To get a Kelvin temperature, you take the Celsius temperature and add 273.2. Now one thing, excuse me, both Celsius and Fahrenheit are degrees Celsius or degrees Fahrenheit. Kelvin is just Kelvin. It's just like a Newton or a joule or something to that matter. Because they wanted to get away from using degrees, because degrees also measure angles. So to avoid confusion, they just say Kelvin. Now, look at this example here. It says convert 77 degrees Fahrenheit to both Celsius and Kelvin. There's no direct way of going from Fahrenheit to Kelvin. You have to go through Celsius. So we'll convert to Celsius first, and we'll show you how to convert that to Kelvin. So say 77 degrees Fahrenheit, we're using the formula for Celsius first. The Celsius temperature is 5/9 times the Fahrenheit minus 32. Plug in 77 for your Fahrenheit temperature. 77 minus 32 gives us 45. Take 5 ninths times 45, you'll get 25 degrees Celsius. So that's converting that 77 degrees Fahrenheit to 25 degrees Celsius. Now we want to get the Kelvin. Kelvin temperature is simply that Celsius temperature plus 273.2. So we take our 25 degrees Celsius temperature, add 273.2, you end up with 298.2 Kelvin. So really, 77 degrees Fahrenheit, which is a nice summer day, is equivalent rather to 298.2 Kelvin.